you. So let's find v of t first. Of course, how can I find v of 2 if I don't have v? V of t, as we know, is h prime of t. So nothing new so far. Can anyone give us h prime of t?
15.
Awesome. Yes. So I'll multiply this for you. 2 and 1, 16, 17, and 1, and I think it's 3.
T.
Perfect. Good. So we have the function. Now they're asking us to find v of 2. V of 2 will be 15 minus 3.72 times 2. So quickly, 15 minus 3.72 times 2. I got 7.56. Measurement unit.
Meters a second.
Yes. Please remember, without measurement unit, doesn't mean anything. Good.
Could you please make your decimal point more? Yeah, thank you.
Thank you. Yes, you're right. Good. So now we want to find the distance. I'm sorry, we want to find the time when the distance is 25 meters. So what do I need to do in that case? Then this is not calculus at all. They're asking us to find, I think they're asking us to find the velocity. What is the velocity of the rock when its height is 25? But I don't have the time yet. So how do I find the time? So obviously,
you just plug in 25 as h.
Yes.
Instead of equal to h.
Yes, perfect. So this is a parabola, obviously, with a maximum. So somewhere it starts here on the surface of Mars, and here is 25 feet. I'm sorry, meters. So on its way out, it will cross this height. On its way up, it will cross this height. And on its way down, it will cross this height again. So all we need to do is, as perfectly mentioned already, so we have 25 equals 15t minus 1.86 t squared. Can anyone tell us what type of equation is this?
Quadratic?
Awesome. Yes, of course, quadratic. Obviously, we have to set it equal to 0. So I'll move this to the other side. I will move this to the other side. I will keep 25 over there and set it equal to 0. And now I would like to share my screen and show you. I don't remember showing this before, and I am going to record it so I can post this for you. So where is my record button? Okay, so we go to apps. Not all calculators have this though. And then we go to number 9 and click on polynomials. And this is the degree. In the calculator, it's called order. So this is the degree. It's already highlighted for me in 2. Press enter. I guess it's press graph for some reason. Okay. So I will enter the coefficients in that correct order. 1.86. Then I have minus 15. And then I have 25, positive 25. And then I click on, it should be click on solve, but I guess it's, again, I have to click on graph. Don't ask me why. I'm making sure that I enter the coefficients correctly. Yes, the positive, the negative 15, and the positive 25. And here are our solutions. So x equals 2.35 and x equals 5.71. What do these represent? And I can stop the recording now, right now. Okay, that's all I wanted to add to the to Canvas for you. Okay, so what do I do? What does this mean?
Those are the t's.
Yes, exactly.
25.
Yes, of course. I meant to write t. Yes, of course. Yes. So this is the t1. At this point, it's after 2.3 seconds. So of course, I have to write seconds. So 2.35 seconds. And then from this point till this point, from here till here, 5.71. Now they're asking us to find those velocities. So obviously, remember the velocities will have two directions. Going up, the direction will be positive. Going down, the direction will be negative. It doesn't mean that the velocity is negative. It just says, it shows the direction, okay? If I go to school and come back, my velocity should be positive this way and negative this way, although negative velocity doesn't exist. But coming back, it shows the direction. So of course, I am going to, where's my function? Here's my velocity. And like I always recommend, please put in the velocity in y equals. That is 15 minus 3.72 t, because it's so much easier to plug in. What am I plugging in? I'm plugging in 2.35. And I'm plugging in 5.71. What do you think? Of course, it's the same number. It's close, but expected to be close. But what I meant to say is one positive and one negative. Of course, we round it up, right? I round it up or down depending on what I got for the time. So that's why the answers are not exactly the same, but they should. So V for 2.35 is 6.258 meters per second. And the other one, for 5.71, is negative 6.241 meters per second. But they should be exactly the same. Okay, now, any questions on this problem? Okay, let's look at one more before we look at the first one. I'm trying to work my way slowly but surely to the first one. Okay, so I think I wanted to look at, yeah, this appears to be long, but I think we should look at it. Okay. The height in meters, again, of a projectile shot vertically upward from a point 2 meters above ground level. You don't have to worry about this. This is the 2 meters, right? And this is the initial velocity of 24.5. The formula is given to us. And of course, I'm going to write in the correct order as h of t as negative 4.9 t squared plus 24.5 t and plus 2. Find the velocity after 2 seconds and after 4. So v of 2 and v of 4. When does the projectile reach its maximum height? When it reaches max height. What is the maximum height? I'm copying everything so I don't have to go back to it. Find the max height. And then when does it hit the ground? And what is the velocity? Okay. Perfect. Okay, so V of 2 and V of 4, we just had a similar problem a couple of minutes ago. So let's find V of t and then plug it in. So 4.9 times 2 is 9.8, negative 9.8 t plus 24.5. So I will find, just to make sure again, it's in meters. Everything is in meters per second, isn't it? Yes, meters per second. Perfect. So this will be meters per second, meters per second. So let's plug in this function and then plug in 2 and 4. So now the new function is negative 9.8 t and then plus 24.5. And then second and table. And we wanted 2 and 4. So 4.9 and negative 14.7. Okay, perfect. Okay, now when it reaches the maximum height, this is basically a step closer to chapter 4. We know that this has a maximum. It's quadratic with a negative leading coefficient. So I'll come back to the rest in a moment. Oh, I think that this is, yes, 10. This is 11. Okay. So here is a function, quadratic. Here is the tangent of the slope of the tangent, or the tangent line at this point, and then the tangent line of this point, and then the tangent at this point, and then the tangent at this point, and then here, and so on and so forth. What do you notice that happens at the maximum? What is the slope of the tangent line at the maximum point?
0.
Yes. Which means f prime of x of t equals 0. Or h, since we have h prime of t. Okay? So in order to find the maximum height, in the past, you would do it with algebra. You would say v of negative b over 2a and f, or that function at negative b over 2a. This is the vertex that we learned in 3 classes before this one. But now there is no need for this anymore, because we know that when a function reaches its maximum, the slope of the tangent line has to be 0, because this is a horizontal line. So once we determined the velocity, which is the derivative of this function, that by simply setting this equal to 0, so v of t equals 0, will give us the maximum. So all I have to write is that negative 9.8t plus 24.5 is 0, and find when it reaches the maximum. So t equals 24.5 over 9.8. And that is when 24.5 divided by 9.8. Okay, I got 2.5. So 2.5 seconds. Shouldn't really write the equal symbol here. That's really not correct. So I'm going to erase it. I have to write again t equals. This is not correct here. Okay, to be exact, this is correct. So its maximum height is reached when the velocity is 0, which means 2.5 seconds after it's launched. Now, what is the maximum height? I have to find a function value at that point. So the maximum height is h of 2.5. That is the maximum height. So I'll share my screen again and go to this, plug it in, and it was negative 4.9 t squared, and then plus 24.5 t and plus 2. And I want to plug in 2.5 in this. And that would be the maximum height, the function value. So it's 32. So h of 2.5 is 32.625, and this is in meters. So the time is determined when the derivative is 0, because the slope of the tangent is 0. We set it equal to 0, we find the time, but the maximum, so what is the vertex? So the vertex is 2.5, comma, 32.625. Any questions so far? Any questions?
So you plugged in 2.5 back into the original?
Because it says maximum height. This is the height. The velocity will be 0. I used it to set it equal to 0, right? So in order to find the maximum height, I have to plug back in the time that it needs to get to the maximum, And once I do that, I get the maximum height. Is that okay?
Yeah. Yeah.
Perfect, awesome. When it hits the ground, and what is the velocity? So what does that mean when an object hits the ground? I'm just copying here h of t, so I have it.
That is x-intercept.
Yes, but what do I have to find? Exactly. How do I find the x-intercept? Excellent, yes, yes, perfect. So how do I find the x-intercept? So the maximum height was,
equal to 0.
yes, of course, h of t equals 0 for hitting the ground. Good. Well, I have an app here that I could use for a polynomial. It is already in there. The first coefficient is -4.9. The second coefficient is 24.5. And these have to be in absolute correct order. Otherwise, you're not going to obtain anything. And then I have to solve, and I get, of course, negative time is not allowed, of course. So then t equals 5.08 seconds. So in 5.08 seconds, the projectile or whatever it was will hit the ground. And now in last part, it says, what is the velocity at that moment? How do I determine the velocity at that moment?
Plug 5.08.
Of course, v of 5.08. Negative 9.8 times 5.08 plus 24.5. Negative 9.8 times 5.08 and plus 24.5. 24.5. I don't like this. I always like to put in the function, but in this case, negative 25.284 meters per second. Remember, the negative sign only says it's coming back. It's not going up. It's on its way back. The slope here, the velocity here is positive. The velocity here is 0, but the velocity here is negative. The slope of the tangent line is the velocity. So it will be negative there. Any questions?